If you fill a cannon barrel with gunpowder, you can use the expansion of combustion gases to push the projectile out. This is a conventional cannon. However, because cannons rely on gas expansion to launch projectiles, they struggle to break through speed limits, so the clever you embeds coils inside the barrel. When electric current flows through a coil, it generates an axial magnetic field that pushes the projectile toward the center of the coil. But once the projectile passes the coil's center, the magnetic field reverses and begins to hinder its forward motion. Therefore, the current to the active coil must be cut off, and the next coil is energized. In this way, a continuous forward force is produced, allowing the projectile to keep accelerating as it travels through the barrel. However, electric current propagates at nearly the speed of light, and manually cutting the current would affect firing accuracy. Naturally, this does not defeat the clever you. You install a photoelectric switch at the rear of each coil. When the projectile passes through the sensing zone, the circuit automatically triggers a power-off command. The electromagnetic constraint instantly disappears, allowing the projectile to fly out smoothly and achieve precise firing. To further increase the projectile's range, you add multiple coils inside the barrel. By precisely controlling the charging timing of each coil, the projectile continues to receive thrust as it moves forward. At the same time, you design the projectile with a streamlined, blunt nose shape to reduce air resistance. A V-shaped stabilizer is installed at the rear to make attitude adjustment easier. By fine-tuning the flight posture, the straightness of the trajectory is ensured, greatly enhancing both range and destructive power. However, operating multiple coils requires enormous electrical power, which ordinary power supply systems cannot provide. Therefore, you design an energy storage and power supply unit that uses supercapacitors as the primary source and lithium batteries as a supplement. This system can rapidly release massive currents to drive firing, while also efficiently recharging to provide energy reserves for multiple shots. Congratulations, you have invented the electromagnetic railgun.